Compound events. Compound events, we're going to be doing more than one thing at a time. So we might be drawing 3 cards out of the deck or picking 3 or 4 of anything. So pulling more than one thing out at a time. Before we get to some problems, let's talk about the difference between independent and dependent events. Independent events have no effect on each other. So for instance, when we're flipping coins, the first coin being heads has no effect on what the second coin might be. This is true whenever we're rolling dice, or having children, or anytime we're selecting something with replacement. Because if I have a jar of balls that I'm going to have in my first example, if I pick out one and put it back, it doesn't change what's in the jar. However, things that are dependent, they do affect. So back to my jar, if I pull out a red ball and do not put it back, so without replacement, then I have changed what my jar looks like. So those are dependent. And so that's going to kind of affect the numeric values that I'm going to use when working the problems. Let's take a look at an example. All right, so in a jar, I've got some balls. I've got 4 red, 3 blue, and 2 yellow. I know the probability that Jeff is going to draw 2 balls without replacement. The first one's red and the second one blue. First off, this is a compound event because I'm taking 2 balls out. And so whenever we're having compound events, we're going to be multiplying. We've seen that we sometimes add and subtract with the or and nots and nors. Those are all special. This time when I don't see a keyword, I'm going to be multiplying. Without replacement means once I take out the red ball, I'm not going to put it back in. So here's what the math would look like. The probability of a red ball would be 4/9. There are 4 red ones and 9 total. Times 3/8 for the blue. There are 3 blue, but now there are only 8 total balls in the jar because I already took one out. When I multiply fractions, I multiply across the numerator and then the denominator to give me 12/72, which reduces down into 1/6. Let's keep our same example, but change the problem slightly. We're going to do the same thing, a red and then a blue, but this time with replacement. So I take the red ball out, I look at it, and then I put it directly back in. Again, I'm multiplying because these are compound events. So when I go to take out the red ball, there are 4 of them and 9 total again, so 4/9. But now my second fraction is going to be 3/9. The denominator didn't change this time because I put back in the balls. So this one is independent. The first example was dependent. Multiplying again across the numerator gives me 12, and the denominator gives me 81. So 12/81 reduces down into 4/27. So let's take a look at another one. Same jar, 4 red, 3 blue, 2 yellow balls. But now I'm going to do 3 without replacement, and I want to find the probability that we get all 3 red balls. So it's still a compound event. I'm drawing 3 balls out. I'm just going to multiply all of those. Without replacement tells me that I'm in a dependent situation, so my denominator should be changing. So I'm going to get 4/9 times 3/8 times 2/7. 4 red balls, pulled one out, then 3 red balls, pulled one out, then 2 red balls. The denominator, I had 9, I pulled one out, 8, pulled one out, 7. Multiply all 3 across the top to get 24, all 3 across the bottom to get 504, and that reduces down into 1/21.